All right. Today we're talking about binomial theorem. Guys, this is the binomial theorem. It's on your reference sheet. You do not have to worry about memorizing it. It looks just like the other formulas that you've been using over the past 2 days with one little tweak to it. What does it do? Do you see these guys right here? Oh my God. Could you imagine if you had to FOIL that thing? That would be ridiculous. It would be ridiculous. It would take forever. What about this one over here? If you tried to FOIL it, you'd have to FOIL something 4 times. Ridiculous. Nope. You can use this formula to create these. Piece of cake. I'll show you how. We're going to do that first question that's on your sheet right now. That first question. I'm going to show you how to do it. So just take it down. Here's what you do. If you wanted to, oh my God, look what you would have to do to write this thing out. If you wanted to try and multiply it out, you'd have to do this. Right? What do you guys say to that? No, come on. Nobody's in revolt? Oh, nobody's going to say, oh what? Okay, is that what we say? That's beast? Okay, all right. Yep, that would take forever. You'd have to FOIL the first 2, and then you'd have to FOIL that by the last one. That would take absolutely forever. Nope, we're going to take a shortcut now that we know some formulas. Here's what you do. Take this number over here is super important. Okay, it's where we start with. So we do 3C 0. They always start at 0, this formula. You take this guy right here, okay? It goes in the first parenthesis, and you raise that to the 3rd power, the one that you started with. And then the other one, this guy, this 5, goes in the next one. And we're going to do this calculation. We got to do it for all of them. So you have to go from 3 to 3. So 3C, 3C1, I'm going to show you because it trickles down. These numbers, this number over here starts to move to there. And at the very end, this one becomes a 0 and this one becomes a 3. So this is going to be x to the 2nd. Hold on, that's annoying. Yeah, 5 to the 1st. And then you do 3C2 x to the 1, 5 squared. And then we do 3, whoops. What's the matter, Henry? Don't worry, bud. You'll see. You'll see. You'll see, buddy. We're going to get the hang of it. We're just going to practice. It's nothing more than a formula, buddy. It's nothing more than a formula. It looks very... It does. It looks very much like it. And you have to make one important distinction. You see, the other formulas that I taught you goes NP. It goes NCR, P to the R. And in this formula, the binomial theorem, this first number is this number over here. And then it moves downwards in the other direction. Okay, so be careful. Okay, let's use our calculator. Let's use our calculator and calculate each one of these out. Okay, that is crazy. Don't do that. Whoa, whoa. There's no reason to have 1,000. Type in 3, math, probability, NCR, 0, right? What is that? It's 1. So that's 1 times x to the 3rd times 5 to the 0 is 1. Whoops, let me just, I apologize for that. I wanted to do this in another color so people can distinguish. So it's going to be 1 times x to the 3rd times 1. That's just x to the 3rd. Now we're going to do the rest of them. What's 3C1? Just plug it into your calculator. Good, 3C1 is 3. That's going to be 3 times x squared times 5. That's 15x squared. All right, let's do it again. Talking about the next one. 3C2. What's 3C2? 3C2 is 3 times x. No. What? 30x? 75, man. Yeah. And then the last one, that's going to be 1 times 1 times 125. Yeah. And it makes a lot of sense that it should start at a high number, that the formula should start at a high number and move to a low one, because what happens in these equations? Take a look. Starts at a high number and moves to a low one. Well, maybe that isn't the best example, but what happens when you normally FOIL stuff out? You get like x squared plus 10x plus 25. Starts with a high number, right? Yeah. Okay. So then, hold on 1 minute, Henry, and then I'm going to take your questions. So then here's what you do. You take each one of these individual items that you just calculated, put them all together, and it's as if you didn't have to FOIL. Well, yes. Yeah, you don't actually have to FOIL regularly anymore. You can just do this. Guys, let's play again one more time, something a little bit more difficult, but nothing too bad. Okay, now there's just a minus sign. But there's a 4, so what are we going to start with? Yeah. 4C what, Henry? 4C. Good, starts at 0. Very nice, bud. 4C 0, x to the 4th, negative y to the 0. And then we're going to do 4C1, x to the 3rd, negative y to the 1st. 4C2, x squared, negative y squared. 4C3. Now, if you notice, these things that I'm writing, these exponential powers on top, you know what they're always adding up to be? Yeah, they're always adding up to be 4, or that first term, or this power up over here. They always have to add up to be that, so don't mess that up. They do. They in fact have a pattern to them, but we don't have enough time to talk about it too much. Okay. So there you go. Hold on 1 sec. We're going to calculate them out. So guys, help me out. What's 4C0? That's x to the 4th. Guys, what's 4C1? Hold on. Okay. What about the next one? What do you mean? I'm dumb. I forgot to put it on there. My bad. Sometimes. Nobody's perfect, right? Everybody makes mistakes. That's how much rhythm I have. Henry, you'll teach me. Did I make a mistake? What's the matter? I circled them to keep track of them for me, because otherwise I get lost. And then it's x to the 4th minus 4x cubed y plus 6x squared y squared minus 4xy cubed plus y to the 4th. What? No. Stuff raised to anything raised to the 0 power is just 1. No. Oh, because I always go from highest power downwards and in alphabetical order. So x is the highest, x is alphabetical order, and x has the highest, I'm sorry, highest power and alphabetical. So since x to the fourth and y to the fourth are of the same power, then it goes alphabetical. X to the fourth. Did that answer it? To be honest with you, I go in order that they came over here. That's it. There. Whoa there. So skip down to question number 5 on your worksheet, and here's the problem. So when they ask you to expand out the formula, you get it, right? You get it. But sometimes they ask you to find random terms of that sequence. And it would be really annoying to write them all out. You could always write them out, no doubt. But I'm just going to teach you how to find them without having to write every single one down. What's the last term of this sequence? This is an easy one. So it's got to be 5c5, right? X to the what? Good. 2y to the fifth. This is an easy one. Right? How much is 5c5? X to the 0 is 1. And 2 to the fifth, I think, is like 32. Y to the fifth. So it turns out the last term of this sequence is 32y to the fifth. We got one more problem to do. So it's not that when they ask for the last term, they hook you up. But like, let's just say they ask you for the third term. So hold on 1 second. Here's what you have to remember. Remember, the formula starts at 0. So here's the deal. Remember, the formula starts at 0. So if I'm looking for the third term, you count on your hands. 0, 1, 2. Do you understand? The third term is where it's 2. So it's 5c2. Do you understand what I mean? To the third y squared. How much? Because remember, this first one starts out as a 5 and slowly trickles down. So it was 5 and 0, 4 and 1, 3 and 2. Okay? And what is 5c2? 5c2 is 10. Negative 2x to the third is negative 8x to the third. And this is y squared. Okay, we're almost there. So this is negative 80 x cubed y squared. And in the formula, in the question itself, it said, find the coefficient. You know what the coefficient is? That. That's the coefficient we're looking for.